Quantum field theory is just one sentence. You know, we think about, well, it's two sentences. One is quantum mechanics, the other one is field theory. Quantum mechanics says that there's a very big difference between what you see when you look at the universe and what there actually is. What you see when you look at an electron is there's an electron at a location. When you're not looking at it, there's not an electron at a location. There's a wave function, a space of possibilities that gives the probability of seeing the electron in every possible different location. Field theory is actually, for this purpose, the more dramatic statement. It's that the universe is not made of particles at all. It's made of fields. If you had a little bit of physics education, you might have heard the argument between, is light a particle or a wave? It's very unlikely that you heard the answer. It's a wave. The universe is made of waves. It is not made of particles. Waves are more important. Waves in fields are what the universe is fundamentally made of. Why are there particles at all? That's the quantum part. When you look at the waves, you see particles. What's happening when the light comes to your eyeballs is that there's an electromagnetic wave propagating out from the light bulb. When your eyeball sees it, it's in the form of individual flashes known as photons, particles, packets of energy. But that's not what fundamentally exists. What fundamentally exists is the electromagnetic field. It's only your perception of it that is in the form of these packets called particles. And that's not just true for photons, that's true for atoms, for electrons, for quarks. There's an electron field, there's an up quark field, there's a down quark field, and when we look, the vibrations in these fields are what we perceive as particles. What is the world made of? It's a set of fields, a set of numbers that fill space. What is the value of the electromagnetic field, the electron field, the gravitational field, and so forth? And quantum field theory applies quantum mechanics to this and tells you how the world works. So very roughly speaking, if you have a wave, if you have a field that fills the universe and it's jiggling, the height by which it jiggles, the amplitude, tells you how many particles you will see when you look at it, or the strength of the force you are experiencing. And the wavelength that you see tells you how far that force stretches or how heavy that particle is. There's a little translation dictionary between the field language and the particle language. And why is this important? So actually, I don't have the 3 hours. That was it. That was quantum field theory. Thanks.